What is going on, guys? My name is Brent and welcome to part 17 of my tutorial series on how to create the game Super Mario Brothers. So in this tutorial, we're going to continue talking about the anatomy of our Goomba, our Mario enemy here. We are going to be implementing some stuff so that when Mario jumps on the Goomba's head, the Goomba is smashed, and also Mario gets a little bounce up like seen in the original Mario. So if you're interested in that, go ahead and stick with me. Only one minor housekeeping item to take care of. Inside our define enemy in the Goomba class from the last tutorial, we're going to change the position.set to getX and getY. That was just an error on my part because we set the position when we create the Goomba, so we need to make sure that the box 2D body is at that position. During the course of this tutorial, some of it will start out with the Goomba non-visible, the texture, so we can see basically the debug lines for our box 2D body. So we're going to just go ahead and comment out the render part of our Goomba so we can see the structure. So in order for us to tell between the difference between Mario colliding with the Goomba head on into his body and Mario jumping on its head, we need to create a head fixture in box 2D that's associated with our Goomba. So inside of our Goomba class, we have our define enemy, and we are going to create the head here. And the first thing we're going to do is create a new shape, a polygon shape. Polygon shape head equals new polygon shape. And a polygon shape takes in a list of vector2 vertices. So a vector2 array called vertice, I guess, equals new vector2 array, and there's going to be 4 of these vertices. Now let's go ahead and define each one. A vertice 0 equals new vector2, and these are all in relation to our origin in the middle of our box 2D body. We're going to say -5, so 5 to the left and 8 up. If you remember right, our radius is 6, so this will go about 2 above the top of our circle body here. And then we're going to scale both of those quantities by 1 over Mario Bros .ppm. Now let's go ahead and copy this 3 more times here. Change these to 1, 2, and 3. And then we're going to change this one to a +5. So 5 to the right now and 8 up. This one will be -3 and +3 and 3 and 3. And shortly you'll see what this looks like. Now we can reuse our fixture definition, our fdef that we had above, to set our shape. So fdef.shape equals our head shape here. And let's add a little bounciness, so when Mario hits the head, he can bounce up a little bit. We do that by setting the restitution of the fixture. And 1, if it was set to 1, that means if Mario was 10 pixels in the air, when he hits the top of the head, he would bounce 10 more pixels up in the air constantly, back and forth. But we're going to just set this to 0.5, so about half bounciness. And then we'll say b2body.create fixture and give it our fdef here. Now let's go ahead and inside of our Mario Bros create a new collision bit here. Public static final short enemy head bit equals 128. And then we'll go back into our Goomba here, and we'll set the filter for his head to equal that. So fdef.filter.category bits equals Mario Bros .enemy head bit. And then also we're going to, when we create this fixture, we need to be able to access the Goomba from our collision handler, our contact listener. So we're going to set the user data for this fixture to be equal to the class itself. So we'll have access to this class from our collision handler. Thing we need to do before we can test it is go ahead and add a collision with Mario inside the Mario class with Mario Bros dot enemy head bit, so Mario can collide with the head. So actually, one more thing is that when we create our head shape, we need to set our vector2 vertices to that polygon shape. So head.set, and then we can just give it our vertice array. So hitting run and testing it here, you can kind of see that the enemy Goomba has this little hat on. And when we jump on it, you can see that Mario kind of does a little bounce and then jumps off, if I can hit it. There we go. So he kind of bounces up a little bit. Okay, so now it's time to do a little voodoo / black magic on our world contact listener. I've created a new integer called cdef, which I'm calling collision definition. And basically what I'm doing is I'm ORing the category bits of both fixtures when they collide with each other. So if we go to Mario Bros, if Mario collides with a ground bit, a 2 and a 1, it would be 0, 0, 0 for as many as you want, and then the 1 would be the Mario bit and the 1 would be the ground bit. So we would have this value, which is actually 3, is our collision definition. Now down here, what we're going to do is we're going to write a switch statement, and we're going to switch our cdef. Now we could have done this for our head object where Mario's head collides with an interactive tile object, but we're not going to rewrite that. We're just going to leave it the way it is. So we're going to write a case here that the C definition, these two filters get their category bits and OR them together, equals Mario Bros dot enemy head bit ORed together with Mario Bros dot Mario bit. So if Mario collides with the enemy's head bit, then we know we need to execute the following lines of code. We need to find out which fixture is the enemy fixture. So we'll say if fix a dot get filter data dot category bits equals Mario Bros dot enemy head bit, then we know that fixture A is our enemy, and we'll say fix A dot get user data, and if you remember right, we set the user data to the object itself. So what we can do is just go ahead and cast this inside of an enemy object here, and then what we're going to do is say hit on head, and we'll have to define that function shortly. And what we'll do is we'll copy this, and then below here, else if it's fix B that is the enemy head bit, then we'll do fix B hit on head. And I'm sorry, these are both a get user data and get user data here. Now let's go to our enemy class, and we're going to say that every enemy has to have a function, a protected abstract void hit on head function protected. And so we'll implement that inside of our Goomba class. Hit on head will actually be public, so we can access it from our world contact listener. And then let's implement this method here. Generate implement methods on head hit. And so down here we can write the logic for what happens when a Goomba gets hit on the head by Mario. So one of the first things you may want to do when the Goomba gets hit on his head is remove the box 2D body so he no longer has collision with anything or Mario or stuff like that. You would think we could do that on this method here, but we actually can't, because this method is getting called inside our contact listener, which the contact listener is getting called within our world.step function that we made in the play screen in our update method. You can see world.step 6 60 times a second and so forth. So we can't actually delete any kind of box 2D bodies while the simulation is still occurring. You may ask why, and the reason is if you delete a body and it's in mid collision with two different objects, how would the simulation know what to do with that second object when it collides with that body? So you can't delete any box 2D bodies inside the world.step time. So what we're going to do is we are going to create a method or a Boolean value called set to destroy, and we're going to set that equal to true, and we'll create that variable up here, a public, or we'll just do a private Boolean set to destroy, and then we'll also do a private Boolean destroyed here, and we're gonna by default set both of those to false. Set to destroy equals false, and destroyed equals false. So moving on to our update method, the first thing we want to do is to check to see if our object is set to destroy. So we're going to say if set to destroy, and he's not already destroyed. Then what we want to do is say world.destroyBody and give it our box2D body. That will remove our Goomba body from the box2D world. Then we're going to set destroyed to equal true. And then what we want to do is set the region, the sprite visual texture, to the smashed Goomba. So let's say set region to a new texture region, and then we got to get the region from screen.getAtlas.find region and Goomba. And I remember the animation had two graphics, and then the third animation was the Smash Goomba, so that starts at 32 pixels by 32 in the X, 0 in the Y, and then it is a 16 by 16 graphic. There we go. So we only want to execute these two lines of code if the body is, or Goomba isn't destroyed. So else if not destroyed, then execute these two lines of code there. So finally, let's go back to our play screen and uncomment our Goomba draw and then run it, and let's test it. So here we go. We can run into the Goomba, and this is where eventually we'll kill Mario. So we can hit him and move him around, but when we jump on his head, we get the smash animation and a little bounce up for Mario for those fuzzy feelings we get. And that's pretty much it. So yeah, in the next video, we'll talk about getting rid of that little texture of the Smash Goomba after a few seconds, and we'll also talk about moving the Goomba around our game world and reversing direction when it hits objects like pipes and stuff like that. But if you have any questions, comments, or concerns on this video, go ahead and post them below. I'm pretty good about getting back to everybody. If you like the video, go ahead and hit that like and subscribe button, but most importantly, please share it, trying to grow this channel. I appreciate everybody's great comments and feedback. If you're feeling generous, check out my Patreon page. I'll give you 2 big thumbs up for that. I appreciate everybody watching, and I'll catch you guys next time.